Hello, my name is Jonathan Foley. I'm the Executive Director of Project Drawdown, and I'm going to talk today about achieving Drawdown, a science-based and hopeful plan to stop climate change in the near future. But as we think about addressing climate change in the future, sometimes it's helpful to know how we got here and how our recent past has shaped current events. Now, humans have always been changing the environment. Even since we invented fire and came out of the caves, we changed the local conditions right around us. But sometime in the last century, some dramatic change started to happen about how we affected the environment. And we started to change an entire planet, not just our immediate surroundings. If we think about the things that contributed to that, one of which, of course, is the rise of human numbers. Our population started to grow dramatically in the mid-20th century, adding pressure to the planet a little bit. We also, of course, grew as an urban species for the first time. Throughout all of human existence, humans primarily lived in rural places. But starting in the mid-20th century, we became an urban species for the first time. And now most humans live in cities and suburbs around the world. But the truly big story of the 20th century was the rise of a truly interconnected technology and consumer capitalist-driven economy. During the last few decades, the world's economic activity has exploded, far outpacing everything else we're doing, fueled by technology that fuels even more technological development, interconnections in trade, and of course, the rise of a consumer culture everywhere in the world. These things have kind of conspired, if you will, and woven together to change the pressure on an entire planet all at once. And during the last 50 years, what's extraordinary is that the population of the world about doubled, but the world's economy, adjusted for inflation and all of that, grew roughly sixfold during the same time. Twice as many people doing 6 times more stuff. And that put together meant that we've tripled the demand for food, about doubled the demand for water, and nearly tripled the demand for fossil fuels in only 50 years. Just put another way, we've just changed more in the last 50 years than all previous human history and human evolution combined. And that's extraordinary. Those things are putting enormous strains on the planet in many, many different ways. Some of them we can see with our own eyes, like the clearing of rainforest, here showing how between the 1970s and the early 2000s, even the remote parts of the Amazon were started to be cleared to grow animal feed and being shipped all the way to China. And today, about a third of the world's tropical forest has been lost, primarily to animal feed, to beef, to palm oil, and to timber and other commodities. We've also seen how human pressures have really wreaked havoc with the world's water resources, whether it's the Colorado River in the United States, or the Aguila Aquifer, or Lake Chad in Africa, or here the Aral Sea in the central part of Central Asia here. What we're seeing is humans are overtaxing water resources, taking more out of nature than nature can replenish, leaving behind completely wiped out water resources here like the Aral Sea. And as a result, water resources are collapsing all across the world, mainly just from overuse. But the really big story of the last few decades, of course, is not just the loss of forest and habitat and water and all sorts of ecosystems. It's also the incredible changes to the planet's climate system, the atmosphere, the oceans, the kind of physical engines of our planet that regulate our weather patterns and how we live on this planet. And of course, we've all heard the basic story here, that increasing levels of greenhouse gases, particularly CO2, have driven the warming of our world. In fact, CO2 levels have increased since the mid-19th century by about 50%. Other greenhouse gases I'll talk about in a minute are also increasing, and they all fuel a kind of additional heating to the world, causing the world to warm up. So just alongside this increasing CO2 level, the Earth's temperature has also increased about 1 degree Celsius, now a little bit closer to 1.1 to 1.2 degrees Celsius. That may not sound like a lot, but the last ice age on this planet was only 3 to 4 degrees colder than normal. We're already well above 1 degree Celsius warmer than normal, and we are continuing to warm the planet. That's going to have big changes all over the world. Now, I want to mention for a second that the science of this has been known for a long time. In fact, the first person to write about this wasn't Tyndall, a British scientist we often hear about. It was an American woman named Eunice Foote, who in 1856 wrote a paper about increasing CO2 and climate change. Yeah, you heard me right. 1856, not 1956. The science of what we know today as climate change has been around for almost 170 something years. And now it's actually happening in our own world. Now, of course, some people today will talk about how horrible this is and how it seems to be out of control and how our politicians aren't doing enough. And I get that. I understand that. And there's a lot of truth there. But I'll tell you right now, this doesn't mean that it's hopeless. We can always make new choices. Tomorrow is never written until it arrives. And we can always make choices to build a better future from where we are. We can choose a really bad future or maybe a better future. And that choice is still ours. Yes, the world has warmed a degree or so. But what happens next? We'll go to 2 degrees, 3, 5, into a world we wouldn't even recognize? Or do we make better choices and hit the brakes and stop climate change as soon as possible? Well, that's what I want to talk to you about today, is how we can do that and achieve what we call drawdown. Now, again, here's the basic picture. Greenhouse gases like CO2 and methane and others are increasing. They're going up in the air. The higher this curve goes, the more heat's trapped in the planet, the higher the temperature will get. And when that happens, we disrupt more and more of our weather patterns, more and more of our water and food and agriculture and everything. And that's really something we don't want. The higher this curve goes, the worse off we are. So here's our choice. Do we continue to let that curve increase into dangerous territory? Or do we bend that curve and try to change the future? Well, obviously, we do want to bend that curve. We want to get away from danger and make the world as safe as we can. To do that, we have to think about this moment, this little blue dot, the moment when greenhouse gases stop rising and they stabilize. And then maybe they can even start to go down again. That is the moment of drawdown. That's the moment we're looking for. Drawdown's the moment in the future when the levels of pollution, the levels of greenhouse gases that are disrupting the planet stop climbing. It stops getting worse. And then it slowly starts to get better. And that's the moment we stop climate change and maybe even begin to start to reverse it over the long term in the future. Well, to understand how to do this, we do have to pay attention to some of the science. Science isn't the only thing on the table here, of course, but it's a big part of it. And if we ignore the science, we're not going to do a very good job. So the science tells us that greenhouse gases like carbon dioxide, methane, nitrous oxide, and a whole bunch of others are all contributing to climate change. It's not just CO2. In fact, if we look at all the contributors to global warming over the last couple of decades, we see that the burning of fossil fuels, which releases CO2, that's contributing about 62% of recent warming. Most people think it's 100%, but it's about 62%. There are some other things we've got to pay attention to as well. For example, CO2 is also emitted from cement and chemical processes, nothing to do with fossil fuels. But when cement is being made and curing into concrete, it releases CO2 into the atmosphere. So that's kind of important. Also, CO2, a huge source of CO2, is the burning of forest. Tropical deforestation in particular, that emits about 11% of greenhouse gases in warming today. And to put that in comparison, deforestation is around 11%, and going back up again, the United States as an entire country is about 12% of global greenhouse gas emissions and falling. They're about equal, and yet we don't hear as much about deforestation as maybe we should. We also have methane coming from agriculture, primarily from animals and some from rice fields, but primarily from cattle and other things that release methane, but also from the natural gas industry. Methane is natural gas or fossil gas. And when we leak it out of pipelines or out of wells or out of our appliances, that also builds up in the atmosphere, causing significant additions to our warming. We also have another gas called nitrous oxide, N2O, not to be confused with NOx, NOx. Nitrous oxide actually comes primarily from agriculture and a little bit from industry, but mainly it's the story of fertilizer and manure. When we spread too much fertilizer and manures on our farm fields, the nitrogen in the fertilizer combines with air and water and is outgassed into the atmosphere. And then finally, we have a kind of a weird family of gases called fluorinated gases that we mainly use as refrigerants today. So they're used in air conditioners, freezers, refrigerators, and so on. And that number is growing dramatically as many people around the world are getting wealthier. So the story of climate change means we have to think about energy a lot because of fossil fuels. contributing both CO2 and some of the methane, but also materials like refrigerants and concrete, and also especially agriculture, because CO2 from deforestation is mainly the story of clearing land for food, the methane from animals, and the nitrous oxide from fertilizers. So we've got to think really hard about our energy systems, our food systems, and the materials we use to build the world. We also have to kind of stop thinking about the atmosphere as just some static thing. It turns out that this is probably the most important picture in addressing climate change, because it shows that human activities, now not labeled as chemicals, but labeled as human enterprises, like making electricity, making food, our buildings, our transportation, and so on, that stuff is pouring pollution into the atmosphere. Together, this is about 100 units, let's say, of pollution going into the atmosphere. But the atmosphere doesn't sit still. The atmosphere has its own chemistry, its own physics, and it interacts with a lot of biology across the planet. So it turns out that about 40 or so percent of all those emissions put in the atmosphere are scrubbed out of the atmosphere by nature. Forest and life in the oceans and chemistry of the oceans are removing about 40% of those emissions each and every year. Now, as the emissions go up and down, so will these so-called sinks. They are basically in proportion to how much is emitted. So hopefully, as we reduce emissions, we can continue to remove a small fraction of them into the future. But these are called carbon sinks. And right now, they remove about 40% of the pollution, leaving behind roughly 60%. And that's what's building up each and every year in the atmosphere. So to stop climate change, to achieve drawdown, we have to look at both sides of the equation. First and foremost, we have to reduce the pollution, the sources of greenhouse gases, to zero, not net zero, just zero. As close as we can get to zero, as fast as we can get there, is the simplest path. And some of that will be easy. Some of that will be incredibly hard. Some low-hanging fruits might be around energy efficiency, stop using really destructive practices, stop clearing rainforests, stop leaking methane out of pipelines and wells. Those are some of the easy things. Some of the hard things we'll talk about later are in our kind of industries, buildings, transportation systems that will require very different kinds of infrastructure than we have today. We also have to continue to support nature. All of the carbon removed out of the atmosphere right now has nothing to do with us. It has to do with nature, healthy forest, healthy oceans. And they can remove some of those emissions. But again, as those emissions go down, this removal will go down with it. But we can still count on nature to remove some of our greenhouse gas pollution so long as nature is healthy. So the two bottom lines here are we have to cut the pollution and we've got to keep nature healthy. And that's how we can stop climate change. So starting with reducing emissions, the sources of pollution, we have to know where they come from. Globally, now these numbers will be very different depending which country you're in, whether it's New Zealand or Thailand or Germany, whatever. But globally, these numbers add up like this. 25% of our greenhouse gases today come from making electricity, mainly burning coal or natural gas to produce electricity around the world. About equal to that, though, is the world's food system. 24%. That's all the food production, agriculture, and land use in the world. Interestingly, making electricity, which gets a lot of attention, and making food, which gets much less, are about equal contributors to climate change, and together are about half the problem. Industrial emissions directly from industry, like making steel, making concrete, making plastics, dealing with waste, and so on, are about 20% of our emissions. Transportation, most of that will be on roads, but also a small amount from planes and ships and trains, add up to 14% of our emissions, so how we move things and us around. Buildings are very interesting because buildings, of course, consume much of the electricity that's being produced, and they use a lot of the materials that industry makes, and they're also responsible for driving a lot of how our transportation system works. And on top of that, buildings emit directly another 6% of global emissions from the building envelope itself, from the boilers and furnaces, hot water heaters, leaking air conditioners, and so on, from within buildings. So there's buildings with 6% of emissions, but then the built environment is close to half of global emissions are kind of linked to the built environment, and that's really important. We have other emissions as well, the remaining 10%. A lot of that is actually coming from the energy business itself, from the refining of oil or the leaking of natural gas and other kinds of things. But the other 5 areas, a little bit easier for us to see, 5 areas are 90% of emissions: electricity, food, industry, transport, and buildings. So right here in one hand, we've got 90% of the problem. And we can find solutions. Electricity, let's start there. We know that the burning of fossil fuels of coal and natural gas produce the CO2 that's the problem here. So we can find ways to make electricity that doesn't use coal and natural gas, renewables, nuclear, all of that. We'll talk about that. But also we can reduce the amount of electricity the world uses in the first place through energy efficiency. And most of the electricity in the world is used in buildings and in industry. So when we think about solutions to climate change from the electricity sector, first and foremost, I look for energy efficiency standards, how we can increase the efficiency, use less electricity overall. And in tandem with that, how do we start to shift away from coal and gas into ways of making electricity that don't release greenhouse gases? And we have lots of those: wind, solar, many varieties of that, in fact, geothermal, nuclear, ocean power, tidal power, biomass, all sorts of things. So let's be more efficient and then shift the production to low carbon technologies. The same kind of pattern will show up again and again and again. Efficiency first, and then pivot next. We have to do both. In food and agriculture and land use, we find that the emissions of greenhouse gases here primarily come from not local food, faraway food, or organic versus GMO. That stuff doesn't even really show up that much. What the really big story here is deforestation, clearing rainforests, for example, to grow more beef or more animal feed or more palm oil. That's the big driver here. Second would be methane, mainly from animals. Our meat addiction, so much meat and dairy production around the world, much more in rich countries than we should be eating from a healthy diet point of view, it turns out. We need to really rethink the agricultural systems and the animal agriculture in particular. How do we address this? Third is nitrous oxide emissions from overusing fertilizers and manure around the world. There's other things here as well, but the big 3 areas in the food system are deforestation, too much meat and dairy, releasing methane, and too much fertilizer. We need to think about all of that. And what we can do here, of course, is be more efficient. Over on the left, showing how we can reduce food waste. 30 to 40% of all the world's food, everything we grow on this planet, is never even eaten. So that's a huge opportunity by reducing the amount of waste. Second is how much meat some countries eat. Not all, and nobody's saying everyone should become vegan. Meat and animal products are very crucial parts of food systems in many parts of the world. But where there's excess, where maybe doctors are even saying we should be eating less meat and less dairy, if we dial that down a little bit, it has a huge disproportionate outcome on agricultural emissions. That's really important. And then we can take the remaining meat and dairy we still use and grow it better with what we call regenerative agriculture, so it emits less also. So a little less waste, a little better diets, and growing food better are some of the solutions we have here. And that's going to be very, very important. We also see emissions from industry, of course. Industry has enormous, very complex greenhouse gas emissions, but the big story here are things like metals, making steel and other metals we use around the world. Cement, that's a huge standout area. Chemicals, also plastics and polymers, things like this. Those are all a couple of percent, but every percent matters. Dealing with all the world's waste, whether it's solid waste or wastewater kind of issues we have around the world, that's another 3% right there too. These solutions are going to be a little bit trickier, but they are in the wings and lots of opportunities to do better here. Transportation, this is a big one, of course, 14% in whole, and most of that is on our roads. We see about 10 of that 14% is all the road vehicles in the world. Flying, the military and civilian aviation emissions of the world add up to a little less than 2%. And then we have ships, rail, and everything else, another couple percent. And again, every percent matters when you're looking at big global systems. We need everything here. Buildings, again, on top of the materials they use and the electricity they bring in from a power plant, emit an additional 6%, most of that in residential buildings. Now, yes, we can build new buildings that are far more efficient. That's great. But we also have to go back and retrofit the hundreds of millions of structures already on this planet. And for the first, in most of the world, to first approximation, the buildings we're going to have in 2050 are already built a long time ago. And we have to retrofit as well as build new. So if we move beyond reducing emissions, which there are hundreds of opportunities for, and we've evaluated many, many of them, we also have to look at how nature can continue to remove some of the remaining emissions, and how we can do what's called carbon removal. Now, again, there's a lot of hype about this right now. A lot of technology folks, a lot of oil companies are talking about carbon removal, direct air capture, all these things. But to first approximation on this planet today, that is zero carbon. We can't even measure it. The atmosphere doesn't even notice it. We couldn't even bear to detect it in the atmosphere if we tried. All of the carbon removal that's really happening on this planet today is from nature by about a factor of 1,000,000 times larger than all the things humans have tried to do so far. So for now, at least, this means we have to make sure that forests remain healthy so they can soak up more carbon, and that oceans are more healthy so they can continue to soak up carbon. So we need to learn how to protect and restore land and ocean ecosystems and make sure they can be healthy and continue to help us reduce the threat of climate change. And then, yes, we might have some very clever breakthroughs soon in how to remove carbon out of the atmosphere ourselves using machines, or by farming differently, or planting new plantations and forests, all those things. So we'll see some breakthroughs in this in the near future, but right now we have to focus on nature's part, and then we can get clever with technology and add that in later. That would be great. But altogether, I hope I can show you that in the big picture, there are many different areas where we have to focus to address climate change, and they're abundant. There are so many things we can do. In reducing sources of the pollution right from the beginning, we have lots of things to do in electricity, in food, in industry, transportation, and buildings. And most of them are right here already. We don't really have to wait for new technologies and new solutions. We have almost everything we need now. In addition, we can work with nature and protect it, restore it, and kind of maintain and even enhance the carbon sinks that are already there and help remove some of the remaining emissions as we begin to drive them towards zero. If we do that, we have the opportunity here to basically stop climate change as early as the 2040s. If we're really aggressive about it, that might be increasingly difficult, through the 2050s into the 2060s. And this is still possible. And if we do that, we still have a good shot at stopping climate change within the Paris Accords. You might have heard about that a lot. The Paris Accords say we should try to stop climate change between 1.5 degrees, ideally, or 2 degrees as kind of the worst case scenario. Right now, we're headed towards probably 3 degrees, maybe a little less, with the current path we're on. But the good news is we used to be headed to 5 degrees or worse. We have started to bend the curve, it looks like. We hope, but we have to keep pulling it down and aggressively move so we can still meet these so-called Paris Accords of limiting the warming of our planet between 1.5 and 2 degrees. The lower that number is, the better off we're going to be. So what have we learned? We've learned that there are many solutions to stop climate change. We're going to need many solutions. A lot of them are here now, and we don't have to wait for. Some will get folded in as we go along, and that's great, but don't wait. Also, these solutions can make the world better if we want to deploy them wisely with ideas of equity and justice and common sense, things that help create jobs, that reduce tensions around the world and improve our health and security. These are things that are crucially important. And finally, I really want to stress the importance of time. We have to quickly scale what we have now. We can't wait for the big new invention 20 years from now. We don't have time for that. To address the Paris Accords, to really keep warming between 1.5 and 2 degrees, we have to be dramatic. We have to cut emissions something like in half in the next decade or so. And to do that, we need some big, quick wins right away. Huge improvements in efficiency, reducing leaks of natural gas, stopping deforestation, and things that instantly can turn on right now and affect the atmosphere. We also have to start right now rebuilding all of our infrastructure. Remodeling every building in the world, every automobile, every airplane in the world, every farm in the world, every industry in the world needs to be swapped out and updated. To do that, it's going to take years and years, decades even, and trillions of dollars. The good news is, though, it's going to build a better world, and we're going to be a lot better off for it. We also can look at things that will play out better in the long run, like planting more trees or farming now differently, will pay off in future decades as those soils and those trees absorb more carbon. And so these kind of nature-based sinks that we could add to will play out, but it takes decades for them to build up that carbon. They won't affect the air today, but they will help us in the 2040s, and that's really good. And also new technologies that could be around the corner, but most of the time it takes years or decades for those to get scaled up. So let's keep inventing and innovating and hope that we'll bring on more and more solutions in the coming decades. That we need to have all of these waves of climate action working simultaneously, the fast ones, the medium speed ones, and the long ones. And we need to look at the different scalars that bring them to scale across the world, how we change policy, how we deploy capital, how we change business practices and labor, and how we change technology and even behavior around the world. Not just one of those is changing the world. I know policymakers think it's policy, technologists think it's only technology, activists think it's behavior or whatever. It's all of the above. We need everything and usually pull these in tandem, and that's when we can change the world. So I think of climate change as an enormous challenge, of course, something that we have to address, but I also see it as an enormous opportunity that we get to address. And so I think about how we can reimagine this world and make a better one where we avert climate change, but we also build a better, more healthy, more equitable, and more sustainable world for everyone. So here's my ask of you. Please learn more. We all need to learn more from everyone and share what we know with others. No one discipline, no one group, no one individual, to be sure, has enough knowledge to even begin to do this alone. We have to collaborate and share and learn always. And finally, I'd like to remind you all that the future is always being written. If someone says it's too late, it's not going to change, we can't do it, why are they raising the white flag of surrender already? We don't have to. We can always build a better future than the one we're headed toward. We can change every day. And I'd like to remind you that Robert Wilson once said, the future is up for grabs. It belongs to any and all who'll take the risk and accept the responsibility of consciously creating a future they want. And that's what I hope we can do too. So thanks so much for your time, and I enjoyed being here today. Thank you.